All right, today, welcome. What we're going to talk about is the relationship between slope on a graph and velocity on a position time graph. So let's go for a walk. Let's say that you're going for a walk and you want to walk on a number line. So if you're looking at this right now, you've probably already done a lab in your physics class where you took a walk. If we were in school, we might walk and drop bean bags, and at home, we walked and dropped socks. And so you are going on a walk and you want to record where you're going. So you need to define an origin, your starting point, which we often call the 0 point. We're going to say at time 0, you're at position 0. Backing up, you also have a positive direction that you've defined and a negative direction that you defined. It doesn't matter which way is which. You're just making the decision. One is positive, the other has to be negative. All right, so you go for a walk. 1 second later, the person is at position 0.5. 1 second after that, they're at position 1. 1 second after that, they're at position 1.5. And 1 second after that, they're at position 2. And so this is a snapshot that you see right here. Imagine if you dropped socks and each one of these people images is a sock. This is a snapshot of where you were at time 0, time 1, time 2, time 3, and time 4. All right, so what does this mean? Let's think about what this means in terms of fastness. So in the first second, you walked 0.5 meters in the positive direction. So that's 0.5 meters over 1 second, which is 0.5 meters per second. We're saying the positive there because we're putting a direction on it. In the second from 1 to 2, you also walked 0.5 meters in the positive direction, so 0.5 meters in that 1 second. It's positive 0.5 meters per second. Same with the third, 0.5 meters in 1 second, so positive 0.5 meters per second. And the same with the fourth. In 1 second, you went 0.5 meters per 1 second, 0.5 meters per second. All right, so we would say that you walked with a velocity of positive 0.5 meters per second. So velocity might be a new term here. Think of velocity as speed with direction. So your velocity here is constant because it stayed the same each time. Each interval, each second interval, it was positive 0.5 meters per second. All right, so we can also put this into a data table. So you see in the corner there, we just took all of these coordinates, 0, 0, 1, and 0.5, and so on, and put them in the data table. And then you could graph them using Excel, Google Sheets, or any other method. Okay. So let's look at this graph and think about how can we determine the velocity from the graph itself. So we wanted to do this, we want to determine the slope between time 0 and time 1. Okay, so we need to pick coordinates if we want to find the slope between this point and this point. So we're going to define some points. So X is the symbol in physics used oftentimes for position. T is for time. And X sub I means initial position. T sub I means initial time. So these are the coordinates for this first point, if you were to put it in symbols. The coordinates for the second point would be final position, XF, final time, TF. And you see that data table right there to define those terms. So we know from math class that slope, you think of it as rise over run. And that rise over run, the rise is the change in position here, because this is a position time graph. It's not just y versus x. So the change in position divided by the change in time, because it's the rise divided by the run. So if we substitute our numbers, we say, oh, well, 0.5 minus 0 divided by 1 minus 0. And that gives us 0.5 meters per second. And that is a positive value. That was our velocity. So the big idea here is that the slope on a position time graph, the slope is the velocity. So if you find the slope, you have the velocity. So if you're asked about, if you have a graph and then somebody asks you, what is the velocity? You find the slope. All right, so let's find the slope between the next time interval, 1 to 2. We do rise over run, we substitute our values again, and you see that you're going to get the same velocity. Well, what you notice here is that if the slope is constant, that means that the velocity is constant. So we know that this slope is constant because it's moving up and to the right at the same rate. If this were a ladder, the steps of the ladder are the same the entire time. And we see this with the third interval, same velocity, same slope. And the fourth interval, same slope, same velocity. All right, so what does slope mean again? Well, maybe in math class you talked about y's and x's and you said, oh, it's delta y over delta x. And so slope, without any context, does not represent anything real. But in physics, if the graph is position and time, then as we said on the previous slide, instead of delta y over delta x, we're talking about the change in position over the change in time. And that does have a physical meaning in this case. It is velocity. Now, the steeper the slope, the larger the velocity. So if you look at these two graphs here, if slope is velocity, that means the slope that has a bigger number has a bigger velocity. So in here, if you ask yourself which one of these has the bigger velocity, represents the bigger velocity, it would be the red one because it's steeper. Now, if the slope of a line is 0, then it would have 0 velocity. So what does that mean here? It means as time is increasing, there is no change in position. The position stayed the same the entire time. So time went forward, but the object stayed in the same position. That means the object is not moving. So therefore the slope here is 0, which means the velocity is 0. You can also have a 0 slope at the origin. And so the position you're at on a number line when you choose to stand still could be anywhere. It could be on the positive side, it could be at 0, it could be on the negative side. So a positive slope now also indicates movement in the positive direction. So on a number line, if you have a positive slope on a number line, that means you're moving in the positive direction, away from the origin, away from that 0. A negative slope means that you're moving in the negative direction, and in this case it means we're moving towards the origin because we start at a positive position, that's our starting point, and we move towards the 0 origin. Okay. So if we put it all together, we say that, hey, in this top graph, this positive slope has a positive velocity. It's moving in the positive direction. It's moving away from the origin. This negative slope means it's a negative velocity moving in the negative direction. The object is moving towards the origin. And this slope right here, which is 0, means no velocity. The object is not moving, it's at rest. And that is our presentation.